This is lesson 84, and we're going to be doing radicals first. And the radicals are, we did some of this, the square root of 50, and then you do the prime factorization, and you get 5 as a prime number times 2 times another 5, and then to simplify, you end up with 5, take the pair out, square root of 2. Now, this is also the same as this. Okay, so you can have the square root of 5, square root of 2, square root of 5 multiplied together. You get the same answers, whether it's under the radical sign or separate. Okay, so that's just a little bit of a review there. So if you've got the square root of 2 times the square root of 3, that is equal to the square root of 6. Or it can be written, this is the simplified form, this is the simplified form, square root of 2 times 3. These are all the same, okay? Now, you want to get them to their simplified form. What if we have, let me erase this here. What if we have 4 times the square root of 3 times 3 times the square root of 2. Okay, how do we do that? Well, we will multiply the whole numbers, 12, and then we can multiply the radicals, square root of 6. And that is the simplified form. Now remember, when our radicals were added, okay, we're multiplying right now, but when they were added, if they were like terms, because you're thinking of these radicals as x's and y's, if they're like terms, then you could put them together. As I have 4 of them, I have 3 of them. This is when we were adding. If they were different, you could not combine them when we were adding. Okay, but now we're multiplying. And so when we multiply an x, say this is an x and a y, those numbers can be multiplied together. So we have the whole numbers, 12, and the radicals multiplied together. Okay, let's do another one. If we have 4 square root of 3 times 6 square root of 6, we can multiply the whole numbers, giving us 24 square root of, multiplying these two, 18. Now, this is not in simplified form because we can break down this. So let's break it down. Prime factorization. We have 2 times 3 times 3. It's 18. Pull that out. So we have 24 times 3 square root of 2. And that becomes 72 square root of 2. That is the simplified right here. Okay, now they're going to throw in a next one here, and this is you're going to be distributing. Okay, so we have 5 square root of 2, and then plus 6 square root of 3. So we're going to distribute these and multiply, and just go ahead. Don't try to shortcut. Just go ahead and do your whole number, 4 times 5, 20. 3 times 2, square root of 6. Plus 4 times 6, 24. 3 times 3, this is 9. Okay, then you look at this. Is this in the simplified form? Well, the prime numbers for 6 are 2 and 3. That's in the simplest form. What's this? What's the square root of 9? It is 3. So you're going to do 20 square root of 6 plus 24 times 3. So the answer is 20 square root of 6 plus 72. That is this simplified form. Okay, I'll leave that up here for a minute. So that is basically all they're covering in this lesson on the radicals. So next we're going to go to some more functions. And remember we did that in lesson 82. But in this lesson 84, we're going to talk about it a little bit more. So we had, they're going to use what they call a function machine, okay? And let me give you some examples. They do like so, 4 and 2, and these are the domain, which means these are the x values. This is the range, which is the y value. Okay, so when we have a domain or an x value, it must be directly associated to one range. Okay? So your domain must be directly associated to one range. So let's look at this one. These are called the little function machines. This is actually what these points are 4, 3, and 2, 3. Okay? X, Y. And that's what we're doing. We're looking at points that are functions, okay? That will produce functions. So if this one relates to 3 and this domain relates to 3, that is a value related to one range. This is a function. Okay, this one is a function. Yes. If it is this form, say it looks like this, 4, 2, 1, and this is 3, 5, 6, and this relates to this one, this relates here, this relates here, then these are also points like this, 4, 3, 2, 5, 1, 6. Each domain, each x value relates to a y value. This is a function. Yes. Okay, let's look at some more examples. Say we have, okay, they're going to give you these looking in this form. Now we have letters, Y-A-M. So, and here we have P, X, S. This is your domains. The domains are always first, and these are your ranges. X, Y is what they represent. And this one, let's see if I can. This one relates to P. This one relates to X. But M relates to 2 ranges. This is not a function. No, not a function. Because one of the domains relate to two ranges. And that's not the rule, okay? That's not what it's supposed to be. Okay, what if it's like this, and you have A, 4, and 7, and you have 5 and 11. Okay, A relates to 5, 4 relates to 5, and 7 relates to 11. This is domain and range. Well, all of our domains relate to one range. Unlike this one, our domain, one of our domains relates to 2. Here, each of our domains relate to 1. So this is a function. Yes, it is a function. Okay, then the other thing they're going to do, okay, so this is pretty easy to understand, I think. The other thing they're going to do is give you sets of numbers, okay? So they're going to write them straight across here, but I would write them down because I think that's easier to look at. And they ask you, is this a function? Is this a function? Okay, so if you put it in the box, if you want to do this until you start to see it, you're going to put your x values here, these values here, and you have two of the same x values that relate to two different y values. So this is not a function. This is not a function. Then you have two of the same, so in other words, it's like this. 4 relates to 6 and to 5. No, it's like one of those other ones we just did. This is not a function. Okay, what about this one? What if I have these points? What if I have 4, 8, 15, 6, and 11, 7. Okay, 4, 15, 11 in one circle, and 8, 6, and 7. This is a function, isn't it? Every domain directly associates to one range. This is a function. Yes, it is. Okay, so that's a way to tell if we have functions or not. And are they doing even more? Oh, okay, well, so we have a few more. I'll go ahead and do a few more. What if we have something that looks like this? If we have something that looks like this, and this relates to this, and this relates to this, and x has no value that relates, is that a function? 5 doesn't have an associative range, does it? So it is not a function. No. Okay. Okay, so that concludes lesson 84. We did radicals, multiplying radicals, and more talk on functions and what they are and how you recognize them. And functions are basically lines you can graph. Some type of line. It could, whether it be a circle, parabola, whatever. what you can graph on a graph, some type of line. Okay, so based on this, you'll have your lesson, your homework sent to your mom in email. So that concludes lesson 84. Thanks.